Hi everyone, I'm going to make series of videos on top 1000 proofs in mathematics. Okay, so in this video I'm going to start proof 1. Okay, so here is my proof 1. So I'm going to start with integration. Proof number 1, integral x power n dx is equal to what? So integration, this is first fundamental basic formula in integration. Integral x power n into dx is equal to x power n plus 1 by n plus 1 plus c. So here c is called constant of integration. C is called constant of integration. Constant of integration. And remember here in denominator we have variable n, so n not equals to minus 1. If n is equal to minus 1, minus 1 plus 1 0. So finite by 0 in general, finite by 0 is not defined. Okay, so anyhow, how do we get this formula? So this is actually basic intention of making all these videos. Okay, so we are going to prove this formula. Integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. So in this video we are going to derive this formula. Okay, let's start. Okay, first of all, what is integration? So what is integration? So integration is a process of finding antiderivative of a function. Antiderivative of a function. So reverse process of differentiation. Reverse process of differentiation is called integration. Okay. So reverse process of differentiation, nothing but antiderivative. Finding antiderivative of a function is called integration. Okay. So differentiation ki reverse process emutundi integration. Finding antiderivative. For example, let us consider one example. Suppose there is a function f of x is equals to x square. F of x is equals to x square. So find the derivative of this function. Derivative. So derivative of this function with respect to x. D by dx of x square is equal to what? 2x. D by dx of x square is equal to 2x. So how do we get this value, this function? D by dx of x power n is equal to what? D by dx of x power n into x power n minus 1. This is the formula for d by dx of x power n. We can derive this formula using first principle of derivative or first principle of differentiation. Okay. So anyhow, d by dx of x square is equal to 2x. Okay, now because here x square n is equal to 2. So 2 into x power 2 minus 1 means 2x. Now antiderivative. Let us find integration. Antiderivative means reverse process of differentiation. Reverse process means here my original function is x square. Derivative of this function is 2x. So x square ki differentiation cheste 2x vachindi naku. Okay na, x square ki differentiation cheste 2x vachindi. Antiderivative means reverse process. So what is now integration of 2x? Okay na, antiderivative of 2x will be x square. Okay na, so from derivatives, derivative of x square is 2x. Now antiderivative means reverse process. This is original function, this is new function. From new function, using antiderivative or integration, we will get x square. సో దీనికి రివర్స్ మళ్ళీ ఏంటంటే మనం ఏం చేస్తున్నాం, యాంటీ డెరివేటివ్ ఫైండ్ అవుట్ చేస్తున్నాం. యాంటీ డెరివేటివ్ చేస్తే ఏమొస్తుంది 2x కి x స్క్వేర్ రావాలి ఓకేనా ఒరిజినల్ ఫంక్షన్ ఓకేనా రివర్స్ ప్రాసెస్ కదా we will get original function. Let us see now integration of a new function. This is symbol for integration of 2x with respect to x. So 2 is constant, take out from integration, integral x dx. So anything not there means we can take power 1. So x power n dx. What is the formula for x power n dx? X power n plus 1 by n plus 1. We are going to derive this formula in this video. Okay. So anyhow, x power n formula, let us take this formula as it is. We will see what we will get. So x power n plus 1. Here n value 1. 1 plus 1 by n plus 1. 1 plus 1. 1 plus 1 2. 2 to get cancel. X power 1 plus 1 2 x square. This is the original function. This is my original function. Okay now. So in simple words, integration means anti-derivative process of finding anti-derivative of the given function. Okay now. Anyhow, so let's start this proof. So integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. So constant of integration where n not equals to minus 1. So most of you think why integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. Okay, you may have seen this formula in various textbooks, different textbooks. Okay, let's start the proof. I'm going to start this proof with derivative formula. So we know that d by dx of x power m. Okay no? So d by dx of x power m. X power n or x power m. D by dx of x power m what? M into x power m minus 1. If you consider x power n, it becomes m into x power n into x power n minus 1. If you consider x power n, it becomes n into x power n minus 1. If I consider instead of n, let us consider m. So m తీసుకుంటే ఏమవుతుంది d by dx of x power m is equal to m into x power m minus 1. I just replaced n by m. So this is the formula for derivative of x power m with respect to x. Okay, this is the power formula actually. So this formula is known as power formula of integration. Okay, this is power formula. Okay, so d by dx of x power m is equal to m into x power m minus 1. We know that anti-derivative of this m into x power m minus 1 is x power m. Anti-derivative of this function is this. Derivative of x power m ఏమొచ్చింది వచ్చింది. దీనికి యాంటీ డెరివేటివ్ చేస్తే ఏమొస్తుంది x power m. But we need integral x power n dx. X power n dx. Yeah, look at this expression m into x power m minus 1. So here we need variable n. Here we need variable n. So how do you get variable n here? Let m minus 1 is equal to n. Okay, let us consider m minus 1 is equal to n. ఇక్కడ నాకు n కావాలి. ఏం చేస్తాను? m minus 1 ప్లేస్ లో n రీప్లేస్ చేస్తాను. ఓకే, సో వాట్ అబౌట్ m? From this equation, transpose minus 1, you will get n plus 1. M is equal to n plus 1. Okay, so d by dx of x power. So in place of m, we can write n plus 1. X power n plus 1 is equal to, again what is m? N plus 1 into x power. What is m minus 1? M minus, we already considered m minus 1 is equal to n x power n. Now we have x power n here. So d by dx of x power n plus 1 is equal to n plus 1 into x power n. Anyhow, here we need integral. Okay, so we need integration of this function with respect to x. Now apply integration on both sides with respect to x. Apply antiderivative. Integration means here antiderivative. Apply antiderivative or integration on both sides. Integration on both sides with respect to x. Integral. This is derivative. This is antiderivative. Derivative of x power n plus 1. Okay now. So okay now. The integral derivative of x power n plus 1 with respect to x into dx is equal to integral n plus 1 into x power n into dx. Okay now, with respect to dx. So dx get cancelled. Next, in general, when we apply integration, we will get some arbitrary constant. That is nothing but a constant of integration. Why do we get a constant of integration? Induka c అనేది ఎందుకు వస్తుంది ఇంటిగ్రేషన్ లో? If you observe all integration formulas, you will see plus c plus c plus c. Here c is called constant of integration. Why do we keep plus c here? Because integration of functions or antiderivative of functions is not unique. Okay. Not unique means what? See, suppose derivative of d by dx of let us consider x plus 2 here. Again, one more function, d by dx of x plus 1. So d by dx of x, derivative of this function is what? D by dx of x 1. D by dx of constant 0. You will get 1. So derivative of this function is 1. And what about derivative of this function? So d by dx of x is again 1. And d by dx of constant 0. You will get 1. Here functions are different. Here x plus 2, here x plus 1. But derivative values, okay na? So d by dx of x plus 2 is 1 and d by dx of x plus 1 is also 1. Okay na? Here two functions, derivative of these two functions are having same output. Now let us find antiderivative. Chetam. So in general, if we find antiderivative, we must get original function. So here what is the, in this case, what is the original function? X plus 2. అంటే దీని డెరివేటివ్, దీనికి ఇంటిగ్రేషన్ చేస్తే ఏం రావాలి? యాంటీడెరివేటివ్ చేస్తే ఇది రావాలి. సో యాంటీడెరివేటివ్ ఆఫ్ దిస్ మస్ట్ బి దిస్ and antiderivative of this must be this. But see what will happen. So here new functions, output functions are same. Integral 1 dx is what? You will get x. Again here also integral 1 dx is what? Again x. But in both the cases, here new functions are, original functions are x plus 2 and x plus 1. Here we have x plus 2 and x plus 1. But we got antiderivatives x and x. So this is not exact function. There will be some arbitrary, some constant. That constant is c plus c. Okay. So that's why integration of functions is integration of functions or antiderivative of functions is not unique. You will get different outputs. Okay. So different functions, original functions are different. Okay, even though d by dx of x plus 100, what? Still 1. Okay, and that's why we always keep plus c. So anyhow here derivative, and remember, when we applied integration on both sides, integration to any function, we get some arbitrary constant in result. Okay, problem. So here dx get cancelled. Okay, this is integration, antiderivative. This is derivative. So derivative inverse process is antiderivative. Derivative and integration get cancelled. You will get x power n plus 1. Okay na? So differentiation, integration get cancelled. Okay, this is differential, this is derivative, this is antiderivative. They will get cancelled. Remember, derivative and antiderivative always get cancelled. Rendu cancel అయిపోతాయి. So x power n plus 1 is equal to, so ఎందుకంటే reverse process కదా, they get cancelled. finally we have x power n plus 1. Here integral n plus 1 into x power n dx. So if we apply integration, we will get some arbitrary constant. Just now we discussed why we keep arbitrary constant and all. Okay, plus c. This is, let us say this is small c. So here we are doing integration with respect to x. So n plus 1 is constant now. So take out n plus 1 from integration. So we have x power n integral x power n dx plus c. Transpose plus c. You will get x power n plus 1 minus c. Plus c becomes minus c, small c, minus small c, n plus 1 into integral x power n dx. Next, transpose n plus 1. Multiplication becomes division. So transpose n plus 1, multiplication becomes division. It goes to the denominator x power n plus 1 minus small c by n plus 1 is equal to integral x power n dx. So here n plus 1 is common denominator of x power n plus 1 and c. Now split x power n plus 1 and c, small c, you will get x power n plus 1 by common denominator n plus 1 minus c by n plus 1 is equal to integral x power n dx. Let here x power n plus 1, here we have minus c by n plus 1. Let us assume, let capital C is equal to minus c by n plus 1. So anyhow here c is constant and n is also a constant. Okay, now this is constant though. Let us assume entire this expression as capital C. Then it becomes integral, first of all, x power n dx is equal to, here we have x power n plus 1 by n plus 1 plus this equals to capital C. So this is the formula for integration of x power n with respect to dx. Integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. Okay, this is proof number 1. And next we will discuss proof 2.